Hello everybody, Arjun from Wizards.exe here. In this video, I'm going to go over motor programming. There's a few different modes that you can program your motor in. Before you watch this video, you should watch our configuration basics video so you can learn how to configure a motor. I've configured an HD hex 20:1 motor on port 0, which is called HD hex motor for this video. And a few basic concepts is each motor comes with an encoder built in, which is essentially a rotation sensor. And this is the second wire, not the red and black one, that connects up to your control hub. It's the JST-PH4 pin wire. So, encoder, every time you turn off and turn on your control hub, every time you turn it on, your encoder count starts off at 0. And then your encoder value is measured in ticks. Different motors have different numbers of ticks per revolution, so your core hex motor has 288 ticks per rotation, while the 20:1 HD hex motor has 560 ticks per rotation. Again, whenever you turn off and turn on your control hub, all of the encoder ports are at 0 ticks. As the motor moves forward, the ticks increase, while as it moves backward, the ticks decrease. And there are 4 different modes you can choose for your motor. So there's stop and reset encoder, there's run without encoder, run using encoder, and run to position. So without any further ado, let's get into how to program a motor. We're going to start off with the run without encoder mode, as that's the most basic mode. It does not use the encoder. So I'm going to create a new op mode and call it motor test. There's no initialization I want to do in here. Just there's nothing I really want to do. So in order to actually set the power of the motor to whatever. So when you're going and run without encoder mode, you only really have one block you can use, 2 blocks you can use for your motor. You can reverse your motor direction, and this applies for all of your motor modes. You go to actuators, DC motor, and you can set the direction to reverse. You do this in the initialization blocks, and you can choose your motor. I'm going to delete that just because I don't want to have that there. Or you can set the power of it. So you go to DC motor, you can scroll down, and you can set the power to 1, 0, or -1, anything between -1 and 1. And I'm going to put that in the loop blocks. So I'm going to save this op mode and I'll show you what this program does. All it does is set the power to 1, full speed. So now I have it out here, everything. I'm going to select motor test, hit init, and I'm not going to hit play until I elevate the motor, because otherwise it might do something bad. And as soon as I hit play, you can see that the motor starts running. If I try and give it resistance, or I try and stop it, nothing. It just continues running. Nothing happens. So you can see if I try and stop it, all it does is continue running in one direction, setting power to 1. Nothing else happens. And that's what run without encoder is. It just does what you ask it to, where it just sets the power to whatever you ask it to. And yeah, so you can set it between -1 and 1. This is how most of your gamepad input and your drivetrain controller is going to be using run without encoder. So now we're going to go over the next 2 modes, which are stop and reset encoder and run using encoder. Stop and reset encoder mode is very simple. It just resets the encoder back to 0. It's very useful. And run using encoder is a much separate mode. So I'm going to go back to blocks and go to motor test. You can see it's still the same as I had it before. But now we're going to first initialize our motor in stop and reset encoder, and then run using encoder. So I'm going to go back to actuators, DC motor, and you can see there's a run mode block here. In initialization, first I'm going to set the run mode to stop and reset encoder, which just stops and resets the encoder. And then I'm going to set the run mode to run using encoder. Now, what this does is it first resets the encoder just to make sure that if anything happened before the match, whatever position it is in now, that's 0. And then what run using encoder does is it sets it into run using encoder. So run using encoder mode allows two things. So first, you can use it just like you use run without encoder, where you can just set a power, but then you can also get a encoder position, which could help determine other things. Otherwise, you can also set a velocity to your motor using run using encoder. So I'm going to show you this block here still applies in run using encoder, but then if we go to extended, we can go set the velocity right there. So I'm going to set the velocity. And now you can see that this isn't a weird unit. It's in ticks per second. So that's like encoder ticks per second. So if I want my motor to run in for 1 revolution per second, I'm going to set it to 560 ticks per second, because that's how much an HD hex motor has. So I'm going to type in 560 so that its target is 1 revolution per second. This might be a little bit overshooting it, because if the battery is a little bit worse, it might not work. So it might have been better for me to go at a slightly lower velocity. The other thing that we need to do is that in the first Global 2019 app, the PID F values are not correct for the HD hex motor. And if you don't understand what that is, that's completely fine. We just need to change it to help the control hub motor controller work. So what are we going to do? So what we're going to do is we're going to go to actuators DC motor extended, and we're going to scroll down, and you can see that there's set PIDF coefficients, and we're going to drag this down into initialization. You should do this for every motor you have. Now we're going to set the P value to 1.17. We're going to set the I value to 0.117. We're going to set the D value to 0, and we're going to set the F value to 11.7. If you want to learn more and understand more about this motor PID F value, there is a guide on the First Global website on how to set your motor PID F value and how to tune it. So you should take a look at that. But PID essentially is like a speed controller to help make sure that your motor is going at the correct velocity, target velocity. So one thing about this, if your robot uses 3 HD hex motors and you need to change the PID F coefficients, change it for every single motor you do. So you can just change that. Same with these blocks up here. You do it for every single motor you're using. That needs to be in the correct mode. So now that we've done this, I think it's time that we should test out our HD hex motor and test out this program. So I saved the op mode, and we'll see what it does. Now I have this all out here. I'm going to select motor test, hit init, lift up the motor, and hit play. So what this program was supposed to do is set the motor to rotate at 1 revolution per second, using the encoder to maintain the velocity. You can see that it's doing just that. 1 revolution per second is a bit slower than what it was at full power, so you might want to change this in order for a higher value, as this is not applying very much power to keep it at 1 revolution per second, and I can easily stop this. Yes. So now we're going to get into run to position. So I'm going to go back to the block programming menu. Now we're getting into run to position. And run to position is essentially where you set a motor to a position and then tell it to stay there. And the motor actively applies power to get to that position. And this is very useful for things like controlling your arm or your lift, where the motor will fall, or as well as for FTC teams, this is really good for your autonomous program, as run to position will essentially allow your robot to drive certain distances. So if you want your robot to drive a certain distance, you should probably be using run to position. So I'm going to open up our motor test program. And the way that run to position works is you give it a target position, and then you also give it a power. And the power essentially authorizes it to use X amount of power in order to go to the position. So power should be positive between 0 and 1. Even though your target position can be negative or positive, your power should still be positive. So there's a few differences between this. So even though you might you should stop and reset your encoder initialization, you should only set your motor mode to run to position after you start your program. So you can see I'm going to move that block there, and then if we go to actuators, DC motor, and go to set target position right there. Say I want to set the target to position to 1000, meaning it should rotate a little bit under 2 rotations for an HD hex motor, or it'll go a few rotations, like 3.5 rotations around for a core hex motor. And so I'm going to keep this block right there still because that sets the PID-F coefficients, and since run to position uses the encoder, we still want it to have the encoder PID-F. So now that I set the target position, we want to set the mode to run to position. Simple enough. And now that we've done that, we're going to delete this block right there. And I'm just going to drag up set power block for DC motor, and I'm going to set the power to 1. So now what this program is going to do is it's going to set the target to position to 1000, set the mode to run to position, and then give it enough power to continue running. And for FTC teams in your autonomous program, you don't want to have your run to position in a loop, and unless you're doing an IntelliOp, and of course you're going to need to either use an isBusy block or a wait block in order to let the motor get to its target position. Here we just have the loop block letting it finish the program. So now I'm going to save this op mode and we'll try it out. Now I have my motor test. I'm going to select it and I'm going to hit init, and you can see when I hit play, it goes at full speed because I set the power to 1 until it overshoots it a little bit, and it comes back. And now you can see whenever I try and move it, it always tries to correct, which is great because this is perfect for an ARM or your drivetrain to keep it in place. So that's what run to position does. Now there's 2 more things that I have to go over, and that's how you get the encoder values. For example, if you want to use an if-else statement for your encoder value, and also zero power behaviors. So the first thing that I'm going to go over is zero power behaviors, and then directly after that, I'm going to go over I'm going to go over how to get the encoder value. Okay, now I'm back into our program. The first thing that I said I'm going to go over is break versus float and zero power behaviors. And zero power behaviors are essentially what happens when you set the motor power to 0. And this applies for all 3 modes. So break actively applies power to stop the motor, while float will just let the motor drift off. And how you set them is you go to actuators, DC motor, and you can scroll down and you can set the zero power behavior. The default zero power behavior is break, so only do this if you're setting float. So a good place for break would be on your drivetrain or possibly a lift, while a good place for float would be on an intake, where when you set the power to 0, you don't want to apply a shock load or anything like that, or a shooter would be a great place to put a zero power behavior of float. Here's a video that you can see. The audio isn't as great, but it clearly shows the differences between brake and float.
This is the robot with coast enabled. As you can see, when I let go of the joysticks and the power of 0 is set, The robot does not stop, but it rather coasts till it stops. This is the robot with brake enabled. As you can see, as soon as I let go of the joystick, the robot jolts to a stop, and it doesn't coast.
I'm going to go over how to get the motor encoder. And so you can see right here, there is a current position block. That's where you get the motor encoder value. So right here in the loop, I'm going to add a telemetry block, which you can watch your telemetry video on if you want to learn how to about that. With the current position, I'm just going to call it current position. Now I'm going to save this to op mode, and I'll show you what the telemetry does, and that's going to be all for this video after I show you that. So now I'm going to show you how this program works. First thing I'm going to do is select motor test, hit initialize. This is still using run to position. If I hit play, you can see that the current position is now 1007, and I can move it in a small range around 1000. And that's fine if I can move it a small range. You can tune the PIDF values a little bit more. Take a look at First Global's tuning guide. But otherwise, that's less than a degree when it's at 999. That's a very small amount. That's really good. And you can see you can use this to actually get the encoder position. So you can see when I spin this, I can get the encoder position out of that, which is really nice. And a few other things, you can actually use the gamepad input as direct input for the run without encoder set power blocks, as gamepad joysticks give -1 to 1. That's what the motor with set power block accepts. Thank you for watching this video. Please like and subscribe, and email wizards.exe@gmail.com or comment with any questions. Thank you.